Lesson 2, Client Scheduling. The most frequently used client schedules are for backing up your daily changes for your client nodes. But you can also schedule your restore operations, archive and retrieve, one-time commands, or operating system commands and scripts. There are two modes for client scheduling that we'll get into in just a bit: client polling and server prompted. Client scheduling is known as central scheduling. The traditional scheduler services are started with the DSMC schedule command. Then they're going to remain active even when the backup completes. This means you're using system resources even when it's idle. Alternatively, we have the Client Acceptor Daemon or CAD service. You can install and configure the TSM Client Acceptor Daemon service that will manage your schedule. It's like an external timer. If you're running the web client, you've already got the CAD service running because it's used for your web client. It's going to start and stop the scheduler process as needed. Therefore, it's going to use fewer system resources when it's idle. Central scheduling mode, client polling. With client polling, the process is started by the client. The client is going to query the server looking for scheduled operations. The server will then send the schedule to the client, and the client waits for the start time and begins the schedule operation, initiated by the client. The other mode, server prompted. This starts with the client registering its TCP/IP address with the server. Then it's the server that will notify the client that scheduled operations are ready. Then the client is going to query the server for that schedule and begin the operation. With server prompted, you must be using the TCP/IP communication method. To let TSM know which scheduling mode you're going to use, you can either use the set schedule modes command, followed by any, which is the default, prompted or polling, or you can add this to your dsm.opt, dsm.sys file and have schedule mode polling or prompted. Additional client scheduling options. We have max command retries. This is the parameter that the maximum number of times the client scheduler will attempt to process a schedule that fails. The retry period parameter is going to be the number of minutes for the client scheduler to wait between attempts for processing a scheduled command that fails. The schedule log name, schedule log max, and schedule log retention have to do with maintaining your schedule log. The schedule command disable parameter specifies whether to disable the scheduling of generic commands that your TSM administrator specifies. The managed services parameter is whether or not the storage manager client acceptor service manages the web client, the scheduler, or both. And then the max schedule sessions parameter is used to regulate the number of sessions that the server will use for processing scheduled work. This is the maximum number of scheduled sessions as a percentage of the total number of server sessions available. Additional client polling only options are the query schedule period option, which is how often to contact the server. Remember, client polling initiates the schedule by contacting the server. If you're using server prompted, you'll need to make sure that you have your communication method set to TCP/IP and have the TCP client address and client port. With TSM, you can do pre-scheduling and post-scheduling of processes. For example, you might want to run a command that quiesces a database before you run the backup schedule. When the schedule is completed, you would bring the database back online with the post-schedule command string. Our return codes. Pretty much any process in Tivoli Storage Manager uses the return code 0 for completed successfully. Now with our scheduling, we also have a return code 4, which is the operation completed successfully except for one or more skipped files. Return code 8, operation completed with one or more warning messages, and return code 12, the operation failed with one or more error messages. Randomization. Randomization is the scattering of your start times through the window. This allows you to balance your workload better. By setting randomization to 50%, this is going to specify that 50% of the start times are randomized within the startup window. So not all of your clients will start their schedules at the same time. So we've seen what we can schedule. How do we define our schedules? You can define your schedule with the define schedule command. Schedules are created and maintained in the database by your administrator. You can use define association then to associate clients that are in the domain for the schedule. These are the parameters that you'll be using for defining schedules. You'll need to have the policy domain name and the schedule name. Those are the required parameters for defining a schedule. Type equals client specifies that the schedule is for a client schedule, not an administrative schedule. You can add a description. You'd add an action, such as incremental. Now, by default, when you define a schedule, TSM is going to do a client schedule for an incremental backup unless you specify a different action and a different type. There are also start dates, start times, duration units. All of this is explained under the slide in your student guide. You can also use the Administration Center to define a schedule. Notice that the schedules are defined in the Policy Domains tab. That's because client schedules are tied to a policy domain. When you've defined your schedule, you'll also be associating your client node with the schedule. So this is all one step in the wizard with the Administration Center. So here's an example of doing the command line, defining a schedule for a server-prompted type of scheduling. The backup archive client registers its TCP/IP address with the server sends the schedule to the client, and the client starts the schedule. This is the command line version. In addition to defining schedules, you can update a schedule to make changes, or you can delete a schedule. One type of schedule you can create is called a calendar-based schedule. This is what it looks like in the Administration Center. You're setting this up based on a calendar. We have a date and a time, and then you can run once, repeat hourly, daily, one or more days of the week. You can specify when to run the schedule based on a calendar. Using the Administration Center, an advanced option for creating the schedule would be your priority. One has the highest priority, and the schedule expiration. Here's an example of using the command line to define an enhanced schedule, also known as your calendar-based scheduling. In this example, we're going to do an archive of the home lab tests directory, and we're scheduling it to run the last Friday of the last week of March, June, September, and December, so every quarter. In this example, below the line we're showing the startup window. The blue box is the actual start time. So wherever your startup window is, that's the amount of time the client can start. Doesn't mean it needs to complete. So if we're randomizing and we have a 1-hour startup window, we can say 50% of the clients that we're scheduling will start at different times during that hour. When you're defining schedules, you can also use what's called relative date and time, and that is relative to now or today. So you can have date equals month, day, year, or today plus or minus a number of days. Same with time. It can be hour, minute, second, or now plus or minus a number of hours. You can use the copy schedule command to copy a schedule from one policy domain to another. The command, copy schedule, domain 1, the name of your schedule, LabSys, the new policy domain, domain 2, and the new schedule name. This is very handy if you have multiple domains set up and you want to use similar schedules. We've defined the schedule. Now we need to associate our clients. We do this with the define association command. We're associating the domain and schedule name to the node names. Command line, define association, the name of your policy domain, the name of your schedule, and then you list the nodes that would be included for this schedule, separated by commas. Occasionally you might need to schedule a one-time command. We'll actually be doing this in the class so you can see it run. If you issue the define client action command on your server, if you're using prompted, server prompted, the action begins in 3 to 10 minutes. If you're using client polling, the time interval is set by the query schedule period client option. You can set the client action duration to say how long you want the one-time schedule to remain active. You can use the query status command to view the action as it's happening. By default, schedule priority is set to 1, duration is set to 5 days, and period is set to 1 time. And this is an example of using the query schedule format equals detail command. It shows us our policy domain, standard, the schedule name, this schedule is for client update, the description, this is the Windows Client Code Update Schedule. We'll actually get into this in the next lesson. But this is what your query would look like.